Good afternoon. I'm John Myatt. I'm the networking CTO at Imagine, and really happy to talk about the transition of all this stuff to IP. The first thing I always like to talk about is why. Why would you move to IP? Because SDI works so well. And IP is a means to an end. Our vision and our interest as a company is really in the transition of the workflow items of television production into software-based and virtualized environments. So you can have the flexibility and scalability to produce lots of channels, produce lots of variations, and produce them in a way that's geographically diverse and technologically diverse, so you can have true survivability. IP is a means to an end. IP is the enabler of moving to these software-based workflows. Now, the important thing to remember is that we're in the golden age of SDI routing. So SDI routers have never been better. We have fantastic SDI routers. My product manager likes me to mention that. And SDI is a great solution for the problem it was designed for. Now, when you try to scale to extraordinary size systems or UHD systems, you start to find those limitations. So SDI is not the future, but SDI is part of the present, and we have to work with it and around it and through it as we move forward. So for IP infrastructure, the important thing is that the infrastructure solution has to enable getting there from here in a very organized way so we can get to the flexible software-enabled workflows, also supporting UHD and very high scale. So the ideal solution lets you get there at a pace that makes sense, and that pace is different for every project. The key enabler is to really be on the roadmap of the IT industry, to use switches from people who make switches for a living, to use compute resources from people who make computers for a living, and have the use of real commercial off-the-shelf hardware. Similarly, the workflows that we do today don't change as fast as the technology. So there will always be production, there will always be playout, there will always be distribution, and these workflows change at human pace, whereas the technology which implements them changes faster. And the transition to IP, while it enables growth, it can't presuppose growth. It has to always be a correct size solution for what you're building today and what you need next year. Now, the important part as an industry is for us to do IP in a standards-based way. While we would prefer, of course, that everything you ever purchase was from Imagine, there are some products we don't make. We don't make cameras, for example. So it's important that as an industry, we have standards that are interoperable across all of the vendors so that you can confidently build systems that integrate parts from us and from others into a workflow and an environment that produces television. Now, I've been deeply involved in the development of these standards, and there are a number of open public standards and interoperable products. So if you've been to the IP Showcase Zone, you'll see many, many vendors all together working in SMPTE 2110, and that's a really profound achievement. Last year, there was a smaller event structured just around 2022-6, but this year, it's entirely 2110. And so Imagine is proud to be part of the Video Services Forum, a leader in the SMPTE development of these standards, deeply involved in the Advanced Media Workflow Association, and also, of course, a founding member of the Alliance for IP Media Solutions, or AIMS. Now, IP transport standards are not new in SMPTE. We've had several. So there's the 2022 1234 family, which is all about transport streams on IP. There's the 2022 5 and 6 family, which is about carrying SDI over IP. And these are all multiplex standards. So what's carried in that stream is a mix of video and audio and metadata. And if you're a recipient of a stream, and say you're the audio desk and you wish to get the third audio channel, well, you wind up taking the entire signal just to pick out one audio channel. So there's an efficiency problem there that's quite significant. Now, IP itself is a multiplex. So if you take your Ethernet cable, there's many, many signals in it. So why would we put a multiplex inside another multiplex? There's no sense to that. So that's really what drove the development of SMPTE 2110, was recognizing that the IP fabric could combine video and audio and yet have them be all separately routable and separately switchable. And so that's the promise, especially in live production, that the audio desk can take just the audio, the video switcher can take just the video, the other processors can take just the signals they need, and everything is dealt with in the IP infrastructure carefully. So the SMPTE 2110 family is broken into multiple parts. So there's a system overview and a timing document. There's the uncompressed, the core video standard. There's the core audio standard, which is compatible with AES 67. And there's parts to deal with non-PCM audio and with ancillary data and so forth. I'm very pleased today to say that the core parts of the standard, the video and the audio and the system architecture, are in fact approved documents within SMPTE. And as the editor of the document suite, I'm really pleased to have that part of my life back. We'll see what next week's meeting is. And the other parts are well on the way, of course. There's drafts and everyone's involved. But now as an industry, we can transition from talking about, when will this standard be done, to how do I design systems that actually produce television? What are the design considerations? Because as an industry, we have 30 years of history of how to build SDI infrastructure. There's a lot of things we do without thinking about it because we've done it that way and we've learned that that's a good design pattern. As we move into IP, what is the design pattern? What is the standard way that works for everybody? So a few things I want to mention. As you're contemplating a project, the important factors to get in your head up front are really around these questions. There's scale. How big a system will this reasonably grow to in the life of the project? Because that helps you make some decisions about the equipment you purchase, about how you wire it, how you organize it. How many inputs, how many outputs. Not so different than SDI projects, really. You have better choices in IP, but you still have to think about scale at the beginning of the project. You have to think a little bit about capacity of the video formats. Does this have to do UHD? Does it have to do a lot of UHD or just some? That's important as well. And then the big consideration in IP as you plan projects is really around the devices you'll have, and will they natively speak IP, or do you have to furnish gateways in front of them and behind them? And projects today are a mix of the two. Many products that are new have IP interfaces built in, some do not. Over time, that will all shift. So, of course, you need gateways for anything that doesn't have a native IP interface. The second thing that's very important in IP is to think about redundancy architecture. An SDI, usually you had a patch bay was your redundancy architecture. In theory, if the router failed, you could patch around it. In practice, that was really hard to do, but it made you feel good. In IP, we actually have the opportunity to have a true redundancy architecture. So, what if a switch fails? What if a cable fails? What if a optical link fails? So we use the 2022-7 architecture of redundancy. Every signal is sent down two paths through two sets of fibers, two switches, converged at the end. This provides coverage for all manner of failure modes. This is actually a more reliable system from a mean time to failure engineering sense. It's a more reliable system than SDI. So it's a domain that we've not been in before in television, that all of these things, every single signal, has a redundancy plan. Now, part of designing these systems is really thinking through the capacity. So in the spine and the core switches, we really advocate using 100 gigabit ports. The 100 gigabit ports are the new normal of the IT industry. Yes, you can still buy 10s and 40s and so forth, but that's 2 years ago technology. The 100 gigabit ports really provide huge scale. So sitting through the, on the corner over there, we have a Arista 7504. It's got 144 100 gig ports. From a bandwidth perspective, that's about equivalent to a 4,000 port SDI router. Nobody ever built a 4,000 port SDI router. But that's the smallest modular switch they make. If you need a larger one, glad to talk about that. Now, signals links that are full, so if you have, say, a multi-channel gateway like our SNP, 32 signals in there, that 100 gigabit link can be pretty full. That goes straight to the core. There's no reason to take that through leaf switches and other things. If you have, say, applications running in a Blade server where each one makes a signal or makes two signals, there you really want to use the aggregation switch inside the Blade server to aggregate those things. And then you have maybe one or two ports back into the core. So that way you're really economizing the core bandwidth by moving some of that aggregation out into the Blade server or into the leaf. Similarly, if you have other devices that are still in 10 gigabit, or maybe they have one or two signals per link, the aggregation switches will map that up into hundreds, so that again the signals that go to the core are really quite dense and quite full. This architecture lets you really economize the size of the spine, or the size of that core switch, and that tends to be a cost driver in projects, how big that core switch needs to be. So if you're going to economize something, that's probably the place to start. Now, people always ask me, well, how big do these switches go? And it's interesting. There's what I think of as small spines, so 32 or 36 or 48 port, box kind of switches, and they come from Arista and Cisco and HPE and other, usual providers of high performance networking equipment. And so something like, that 48 port switch there, that's, like a 1500 by 1500 SDI router. That's pretty good for a 2RU box, right? And then when you need larger, really very, very large switches exist. And so, between Arista and Cisco, they make sizes that are all over from, large to very large to really quite large. The good news about using commercial off-the-shelf technology for the core switching and the aggregation switching is that it gives you choices. So you can get the switch that's the right size for your project. And it gives you economic choices. Maybe you have better relationships with some vendors than others on the switching side. Maybe your corporation has a fantastic deal with one of them or something. Using the commercial off-the-shelf technologies for the switching architecture gives you the opportunity to pick the right size thing for the job you're doing. Now, there's kind of three design patterns to approaching an IP-based plant. So one of them is to say, well, I'm mainly an SDI plant today, but I plan to add some IP stuff in the future. And so for that, often we will use SDI routing. Remember, it's the golden age of SDI routing. And we'll drop in some IP cards into the SDI router. So that gives you bridges out into the IP world. It lets you add some IP-based workflow items, but still be based on kind of an SDI in the center approach. It's a very, very low-risk approach. It's a very, deliver and ship and work instantly standard method approach. Another way is to go straight to the end. IP core, some things are connected directly to it, and then there's gateways for things that are not. This is very, very popular as well. This is the most cost-efficient way in the IP side where you say, okay, I'm going to go straight to IP, I'm going to do everything in IP, and I'll just accommodate the devices that need accommodating with gateways. And then there's a down-the-middle approach that says, well, I'll have an SDI zone that's SDI, I'll have an IP zone that's IP, I'll engineer the tie lines and controls between them. And that's also a fine approach. Really, the choice between these is an economic approach and a project management approach. You have to design for your circumstances and your particular needs and wants. And so each of these approaches makes sense. We've had customers take each of these approaches. But it's important to think through that from a control system perspective, we can do any of these. It's really a matter of saying, okay, what is the right design methodology for your site and for your needs? Now, the UHD transition presents some especially interesting problems because UHD, of course, now that HD is all easy and 3 gig is pretty easy, UHD is, of course, 4 times the bandwidth. And it becomes a particularly cost-effective challenge in multi-viewing. You say, how do you organize having high-resolution multi-viewers, particularly in something like a mobile unit where you've got a lot of multi-viewers and a lot of operating positions, and you're going to do a UHD production? So the design approach is to make a HD resolution version of every one of the UHD signals, at least for the purpose of multiviewing. And so the multiviewer array maintains sort of the scaling and sizing and costing, importantly, that we achieve for HD, but yet you can do UHD production. So this is a key feature in many of our products to create that representation of the UHD image suitable for the multiviewer array in order to effectively manage the total system cost. So it's an important consideration as we move into UHD production of how do you manage the bandwidth into the multiviewer array, because the multiviewer can consume as much as half of the total system bandwidth just feeding the pips for the multiviewer. So rather than just talking about the generic, I thought, well, let's talk really about the specifics of a real project that we're right in the middle of executing for our customer TPC. And TPC is a large broadcaster in Switzerland, or SRG rather is a large broadcaster in Switzerland. TPC is part of it. And they're building a UHD mobile vehicle. And we're pleased to be a part of the project, along with several other vendors who are involved in the project. And rather than me talk about his project, we've invited Mr. Latman from TPC to talk about the UHD-1 project.
Hello, everybody. I think it's very helpful for you also to understand what's a customer's perspective in this approach. And I would like to explain you why we are building a UHD IP-based truck. That's basically how it looks like. So as John just mentioned, we have two Arista switches, quite powerful ones, as core. And unfortunately, we need these processors because many of our devices are not yet ready for IP. So basically, cameras, vision mixers, and things like that are connected via these interfaces. But also, the multi-viewing part is completely IP-based. So we will have a proxy level, a 3 gig proxy, HD 1080p 50. But basically, the truck will be built for 21p 50 HDR. And we are under construction for this truck. It will be on the road on 4th of December this year. First production will be on 22nd of December this year, so it's quite a tight timeline for that. Some words about TPC, about SRG. This is Switzerland. We have 4 languages in Switzerland. The biggest one is the German part, where we are as well, based in Zurich. Around there you see all the broadcast channels, radio channels, and multimedia products we are producing. And TPC is a production company with around 700 employees. All the technical equipment and all the technical stuff for the German region is at TPC. So I would like to explain you why we are building the OB van, and I show you a building. So that's the longer-term approach. In almost exactly 2 years' time, this new building will be on air. So at the moment, it's under construction, and it will be a tech building, a technology building with a lot of technical infrastructure in it. You see here the most important part. So we will have master switching, nationwide plus regional. We will have playout centers for broadcast and online event channels. We will have central ingest. We will have a studio landscape with several galleries. And we will have post-production and newsroom for news and sports in this building. So it's a new building, as I mentioned before, and that's why we decided to go to a greenfield approach and not just to rebuild infrastructure that we already know. This building is made for around 40 years lifetime, and I had the challenge to figure out a technical approach that gives us, at least not for 40 years, but for 10, 15 years approach to go into the future on a new basis. And I wanted to introduce IP in this building, but how now figuring out how it works with IP in large scales As I mentioned before, master switching room nationwide plus regional, so it's quite a high bandwidth that we have to handle. Here are some impressions of the new OB van. It will be a 24 cameras, 5.1 audio OB van. Some drawings of it, so a lot of monitors, of course. The main vendors were already mentioned from John before. So what did we figure out up to now? What are the challenges we are facing in? For the new building, we decided to go to a test and certification system. That means for each vendor who wants to answer our RFP, he has to show us the functionality that exists right now. The first TCS was in August this year in Zurich, so it was not just a Plugfest, it was more than a Plugfest, because we just gave some equipment to the vendors and told them, okay, now you can implement it and give a signal on this loudspeaker or on this monitor or introduce that source into your system. And we figured out quite a lot of things. Orchestration. How to run such a system, how to handle the bandwidth. What does it mean for the operator in everyday's production? It doesn't help me to have an IP OB van based on ST2110 uncompressed if it's not working. It has to produce each and every day, and I have to give the trust to my staff that they can work with it. So orchestration is a big issue in the OB van. In our system, it looks like this. We have the SDN controller, which is on the Arista switch itself. So it's the system that runs the switch. On top of that, we have the orchestrator, that's Imagin's Magellan, that we have in there. And for the users, it's the broadcast controller, still called broadcast controller, not IP controller. And that's the VSM from Lavo in our case. And the balance now is to make or to enable people to run this system, not just in a traditional way. So we don't want to copy SDI to IP. We want to get the advantages of IP as well. And we are still figuring out what these advantages in everyday's production really are. And I think the crucial point really is the broadcast controller there. Another important point, timing. It's not Blackburst anymore. It's not tri-level sync. It's PTP version 2. And PTP is well introduced. There are standards. Everybody says, yes, we speak PTP, no problem. But then if you want to introduce new devices, usually the timing is the biggest challenge we figured out is in such a system. So these are the 2 points where we think the difficulties are at the moment, but we are quite sure that the truck will be up and running in December this year, so 3 more months to go. And then we will produce the first big show that you will possibly see as well with the new truck is the downhill skiing in Wengen, so the Lauberhorn. If you don't see it on TV, possibly it's because the truck is not working, but I'm sure you will be able to see this production.
Thank you all.